All right, ladies and gentlemen, welcome back. Professor Connect here. This video is actually for my own personal students instead of making this like a generic video just for everyone. But these are actually practice problems that I give for my own students to practice for their stoichiometry test, because I do combine stoichiometry with a lot of different things. I combine it with things such as naming, balancing equations, learning how to form some chemicals. So really, I do combine a lot of different ideas together in it. So that way, basically, in the long run, I can just keep practicing stoichiometry with them along multiple subjects and multiple chapters. So I'm going to go over specifically certain questions. If you're one of my students, this will be labeled from the honors chem paper. No, it's not an honors class. It's just a paper that I borrow some questions from because I think they're good questions and they're just asked in very interesting and weird ways. So, first question actually gives you a word problem, and it basically wants you to translate that word problem into a chemical equation and balance it. And so it says ethylene gas, C2H4, burns in air to produce carbon dioxide and water. And so it tells you already that you have ethylene gas, C2H4. That's one of your two chemicals. It's being combined with something. The thing it's being combined with is air. And if you guys don't know, air, for the most part, that we worry about in this reaction is O2. It's the air that we actually breathe. So O2 is actually going to be the air that we're talking about. It's going to go through what we call a combustion reaction, which is a special type of reaction, and it'll produce carbon dioxide, which we've already learned naming if you're one of my students, so this one should be easy. And it produces water. Water is pretty straightforward. Everybody probably knows what water is at some point. I do make sure to put a question like this on my own stoichiometry test, so there will be at least one problem where you have to take a word problem exactly like this, which is why I want to go over it, and translate it into an equation and balance it. So once you get to here, if you need to, pause the video and we'll try and balance this guy. If not, I'm just going to go ahead. So I'm going to say we probably need one of these because I have two carbons on this side, so I want to balance it out. Usually what I'm going to do is I'm going to say I have two carbons over here. That'll balance out those two carbons over there. Now, I do need to balance out my 4 hydrogens over here, so I'm gonna put 2 of these guys together. In doing so, that'll balance out my hydrogens, and then I need to count, so I have 2 times 2 is 4, plus 2 is 6, so I'm gonna need 3 of these guys over here in order to balance out those 6. So there we go. This next problem is really weird. I like going over this just so you know, if you are one of my own students, for some reason, this paper that I borrowed from the internet is out of order, so it actually on your paper goes 1, 3, 2, 4. So I'm actually going to skip number 3 altogether. I think it's the most straightforward problem. Jump directly to number 2 if you're one of my own students, if you're looking at this video for review. And you have this weird question, and I actually like this very weird question because it is worded in such an odd way. They give you an equation, and then basically what they do is they say, okay, here's different situations in terms of moles. If Li had 0.2 moles, if O2 had 5 moles, and if Li2 had 1.2 moles. And they basically make you actually translate them. They say in experiment 1, if you had 0.2 moles of Li, and I'll just work out one of these to show you exactly what it's trying to get you to do for each. It basically says, okay, how many moles of O2 would you have? So then you would say, okay, well, this is the number of moles I start with. To get to moles of O2, I use my stoichiometry kind of process, and I go, okay, I'm in moles. I need my mole ratio. So for every 4 moles of Li, according to my balanced equation, I have 1 mole of O2. And then this will actually get me my answer, because all of these answers they want in terms of O2. And so I wanted to work out one of them, physically showing you the process, and then I'm just going to kind of fill in some of these answers that way you can check yourself. So if I do this, I'm going to multiply straight across and then simplify, so this will become 0.05 moles. If you need to, pause the video, start working through some of these. Again, set up your ratio. This is going to be what I want over what I have. So my next one is I'm going to want this over 4, so I'm going to take that, and again, I'm going to divide by 4 again. So I didn't balance this out right. There's a number missing. So it says a 2 in front of it. Luckily, I didn't make a mistake yet when it came to like the math. So this will be double the amount of that. So this will actually be 0.10. Then if I keep going, this guy, I take my 5. I start now with 5 moles of oxygen here. So this now gets replaced with 5 moles of oxygen. I go through my same process. This guy would be multiplied by 4. So I end up with 20 here. Over here, he would actually get cut, or he would get doubled, I'm sorry. So this would become 10 moles here. And then I'd go through this process one more time, and go through and say, well, now I'm starting here and I can go backwards. Remember, it does not matter which order you go in, so you can go backwards. I'm just doing basic mental math because I just know, well, for all of these, I'm already in moles, so I'm just multiplying by my mole ratio. I know I want O2, so this has a mole ratio of 1 in front of this guy. So I can say for every one of those, that guy basically gets cut in half because it's 1/2. This guy gets doubled because it's now 2 or 4/2, so this guy becomes 2.4. So again, I went really quick. I didn't actually show all the math out because I kind of figured that my own students would hopefully start just using this little equation down here, substituting it and checking for themselves. So the next question I want to go over is number 4 on the, like I said, the honors chem review paper. Honestly, honors chem is the same as regular chem. They're the same exact subject. So anyway, you get given a chemical equation. It's already balanced for you. This is very nice, but they ask it inside of a word problem, which is just kind of annoying, but I like it because it's realistic. So if 5 moles of ammonia, and this is probably the word that's going to trip up a lot of my own students, are reacted, how many moles of H2O are made? So first of all, I need to know what this ammonia thing is. So ammonia is actually NH3. Okay, for my own students, if you have a word that you don't know what it means on your test and we have not learned it, just ask me. I will always tell you. And so, if we haven't learned it, if we have learned it, then I'm gonna say, well, we've learned that word before. So, ammonia is NH3, so now I know, okay, I have, let's see, I have 0.5 moles of ammonia, so this is actually where I'm starting. So I'm starting with 0.5 moles, and I wanna get to, so this is again, figuring out what I have and figuring out where I'm going. I have moles of ammonia, I want to get to moles of H2O. So again, going through that stoichiometry process, going from grams to moles to mole ratio to moles of product. And in this case, I'm already at moles, so I just need my mole ratio. So again, I'm setting this up, what I want over what I have. I want H2O, so for every 6 moles of H2O, remember, I get this number from my balanced chemical equation. It was already balanced for me. For every 6 moles of H2O, I have 4 moles of ammonia, 4 moles of NH3. And so I'm gonna multiply straight across, I'm gonna simplify that down, and I'm basically gonna get an answer. My answer for this guy is gonna be 0.75 moles of H2O. And so that gives me at least a good start. This is not every single problem from the honors chem review paper, or basically like part 1 to your stoichiometry test review, but it's a good start. And these are, in my experience, the most challenging questions that also are reflective of what I'm going to ask you on your test. Believe it or not, actually number 2 on this test right here, where I have a little table like this, I actually do borrow this question and put it on your exam. So if you're watching this review video and you decide to take my advice, you already know you're gonna have a question like number 1 and a question like number 2. So you already know what 2 of your questions are going to look like. They're not gonna be the same exact ones, but it gives you at least a heads up. So this has been Professor Connect. I've been trying to, over the past couple videos, show all these connections because now we can do problems like this, where I'm actually connecting multiple things together, balancing equations, solving for grams and moles, making mole ratios, all that good stuff. So hopefully this has been a really good little summative review. I might do a second test review video for my own students, but if you have any questions, make sure to leave them in the comments below. If you're one of my students and you have my email, just shoot me an email. Otherwise, I hope to see you guys in the next video.